Welcome to Amigos IAS. Congratulations to all of us because ISRO has successfully launched Chandrayaan-3 mission. Today at 2:35 p.m. exactly, the launch has happened at ISRO's center and it has successfully placed Chandrayaan-3 in Earth's circular orbit. We will try to see some of the important aspects of this Chandrayaan-3 mission. So, this Chandrayaan-3 mission, we have to understand that Chandrayaan-3 mission is a continuation of Chandrayaan-2 mission. You might have heard about Chandrayaan-2 mission in 2019 at the last stage of Chandrayaan-2 mission where it was called as soft landing. Chandrayaan-2 successfully reached moon's orbit, and while it was placing lander and rover, these are the two important things. While Chandrayaan-2 was placing lander and rover, okay, as the name indicates, lander will carry the payload onto the moon's surface, and rover, after the lander reaches the moon's surface, this rover just like a small device which will move on the moon's surface. So, when Chandrayaan mission 2 was implementing this final stage, there was a technical glitch, soft landing failed. Okay. So, in part with continuation of Chandrayaan-2 mission. So, why I am referring to Chandrayaan-2 mission was, in Chandrayaan-2 mission, where all these steps were taken up, there was an orbiter. Orbiter in the sense, this kind of payload is a kind of satellite which revolves around the moon. It is still revolving around the moon even today. Don't consider that Chandrayaan-2 is a complete failure. No. In fact, the same orbiter which is used in Chandrayaan-2 mission, the same orbiter which was used in Chandrayaan-2 is still being used by this Chandrayaan-3. Chandrayaan-3 in the future will use the same orbiter. So, what is this orbiter, what is this lander, what is this rover? All these things we will know, we will try to understand step by step very briefly. So, Chandrayaan-3 mission uses this rocket which we are calling it as, now it is named as Launch Vehicle Mark 3. Previously it was called as what? GSLV Mark 3. The same GSLV Mark 3 launch vehicle of ISRO is being named now as Launch Vehicle Mark 3, LVM 3, with its minor modifications of GSLV Mark 3. So, they are using this terminology LVM 3. So, if we look at the components, the main components of this launch vehicle, if we call this, basically is a cryogenic engine. When we are calling about cryogenic engine, last stage, upper stage, cryogenics means low temperature, very low temperature. Low temperatures means not 10 degrees or 0 degrees. They will be in below minus 100 degrees centigrade also. So much of low temperature. That is the beauty of this advanced complicated engine. So, this stage, important stage of cryogenic engine, actually the third upper stage, this uses liquid fuels. As they are using liquid fuels, these elements have to be kept in liquid form. That is the reason very low temperatures are required. So, what are the liquids used in third upper stage of our Chandrayaan-3 launch vehicle or rocket? So, if you look at those fuels, they are nothing but liquid hydrogen and liquid helium. What are those? Liquid hydrogen and liquid oxygen. Liquid hydrogen and liquid oxygen, these two are the fuels which are used. Apart from that, not only liquid hydrogen and liquid oxygen, these two will mix and create the combustion will happen and exhaust will happen, burning will come, fuel burning will happen. And there is, as I said, another liquid called liquid helium also. So, generally people will talk about only liquid hydrogen and liquid oxygen in the third upper stage of the cryogenic fuel engine. No, there is a third liquid also which is nothing but liquid helium which is used to maintain the pressure. So, these are the three things: liquid hydrogen and liquid oxygen as a fuel and liquid helium for maintaining the pressure. This is what? Third upper stage, third stage of the rocket, which is called as cryogenic stage. Okay. Then there are the next below two stages will be there, stage 2 and stage 1. Stage 2, when we are talking about stage 2 here, these are L100 liquid stage Vikas engine stages. So, in the second stage, what is being used? L110 Vikas engine is used here, liquid engine stage. This is cryogenic stage, which is third stage. Second stage is liquid engine stage. First stage is nothing but S200 booster. So, 3 stages. I am talking about the launch vehicle. What is the launch vehicle here? Launch vehicle Mark III. So, this launch vehicle Mark III has 3 stages. S200, which is nothing but first stage, Vikas engine liquid stage, L110, third stage cryogenic stage. So, these stage by stage the propulsion will happen anyway. So, this is a very advanced development done by ISRO. Because of this cryogenic engine itself, we are able to launch very heavy satellites, and we are able to do interplanetary, this long distances space missions also, to moon, to Mars. That has become very much easier because of this engine LVM-3, which is nothing but launch vehicle Mark III, or previously it is also called as previously GSLV Mark III. Then we will look into the path taken by Chandrayaan-3. How Chandrayaan-3 from Earth to Moon, the path will be taken, how that orientation will be there. So, if you look at Chandrayaan-3 mission, Chandrayaan, obviously we have to reach Moon, yes or no? It is not that the orbit here or the path of this is a very important understanding which you have to observe. From Earth we have launched it today, yes or no? ISRO has launched this Chandrayaan-3 today. It is not that directly there is moon somewhere, yes or no? We are not launching the satellite or this Chandrayaan-3 mission directly here. It is not a straight line path. Why it is not a straight line path? Why the path is indicated like this? See, it is going, it will first enter a circular orbit, then it will go an elliptical orbits like this, many orbits will be there, then it will go like this, transfer trajectory, finally it will enter moon, lunar orbit. Why it is not going, this is from, why we are not launching a straight path like this? Very difficult. See, these are very huge planetary objects, planetary bodies. They have lot of gravitational pull. Forces will be acting, pulling that mission. Earth will have a lot of gravitational impact on it. That is the reason in the first stage what we are doing, we are launching it in a circular orbit of 100 kilometers around Earth. Today this has become successful. It is not that today itself Chandrayaan-3 has reached moon. Chandrayaan-3 will reach moon on August, around August 23rd. Okay, today this was this first stage of making or inserting the payload in the 100 kilometer orbit around the Earth. This was successful. Slowly this will take various elliptical paths and it will try to reach the moon. But coming back to the first question, why this path? Because as I said, I was explaining briefly here, the gravity will be very higher. That is the reason what we are trying to do here, you can't have the pull of the orbit, lot of fuel will be required. There is lakhs of kilometers distance. Okay, distance is in many lakhs of kilometers. Okay, so you can't have the fuels to carry, to pull away to these things. So what we are doing, we are taking the help of gravity. The gravity of the Earth is being used to launch in this for this mission. So initially what we will do, Earth will be there. Okay, the mission will be launched in a circular orbit of how much? 100 kilometers. Circular orbit. Okay, here now the gravity will be 0. Satellite will be revolving around the Earth. Pull will be 0. As we know the basics of the satellites and how this continuation is done, when a satellite is in orbit, pull of gravity, it will be balanced. The Earth's gravity will be balanced by centrifugal, centripetal forces will be balanced, and there is no need for energy expansion here. So it can be in the orbit without spending much fuel. Fuel is required only for that communication, relays and all those things. Okay, electronic circuitry, only that much fuel is required, not for propulsion. So slowly when this is there, when it is rotating, path will be calculated scientifically, when how we can reach the moon, because moon is in some other orbit. So, slowly it will be there, it will be moving, and slowly it will change the path, elliptical, from circular to many elliptical orbits, not just one orbit, there are many orbits, elliptical orbits. So, slowly it will change, it will increasing like this. Finally, on fine day, in the month of August, see this is July. So, it will take a lot of journey still ahead for the Chandrayaan 3 to reach moon. Almost it is predicted as planned on around August 23rd, 24th. Okay, on August 23rd or 24th, it will try to reach the moon's orbit. So, when it is traveling like this, so that is the reason elliptical orbits. See, different elliptical orbits. Slowly it will be getting nearer to the moon. So, when this orbit size becomes larger and larger, one fine day it will switch to this transfer orbit, and it will try to get inserted into same plan here, slowly coming into the moon's orbits. Again also here, in order to reduce that fuel consumption and to make the mission, because we do not have enough fuel to do this, it is so much of launch vehicles, the capacity is not there to cross all these distances. So, they are using elliptical orbits of both Earth and moon. That is the reason here also elliptical, slowly it will try to change the parts, small modification will alter the parts, and finally it will reach the moon's orbit. Here also 100 kilometers circular orbit around the moon. In the final stage on moon, this is Chandrayaan 3. As I was saying before, this will also have around 100 kilometer orbit around the moon. Then when this reaches, slowly it will have lander, it will eject the lander. The lander will carry the rover, Pregna is the rover, Pregna rover will be carried, and this lander will reach the moon's surface near to south pole of the moon, nearer to moon's south pole. Then after the lander reaches, because this is just rotating around the moon. So, when the lander reaches the moon's south pole, nearby moon's south pole, it will eject what? Rover, which can move on moon's surface. But very interestingly, we do not have a orbiter. This body of the various stages, that will only be used as a communication relay. As I was telling in the initial sentences or initial description, this orbiter, the actual orbiter, after the lander and rover reaches the moon's surface, the previous Chandrayaan 2 orbiter, which is already there around the moon even today, that orbit will be used to communicate with the lander and the rover later. Because we have to know what scientific evidences we can collect from the moon surface, that has to be communicated with the earth. It is not that we just landed there, we need a proper scientific data collection. So, we are using which orbiter finally? We are using the orbiter of Chandrayaan 2, which is already in the moon's orbit. Okay. So, this mission, this Chandrayaan 3 mission does not have an orbiter, it has only lander and rover. Temporarily communication relays will be there, which will be done by the rocket module itself at the different stages. Okay. So, this is Chandrayaan 3 mission. It will be reaching moon around August 23rd or 24th, and then much more evidences about moon surface will be known to us. Thank you.